Hello, welcome. In this video, we will begin to introduce sorting algorithms in chapter 17. We already used one sorting algorithm in chapter 7 when we introduced the selection sort. Selection sort works this way. You select the smallest element and swap with the first element if the first element is not the smallest. And then in the remaining list, you select the smallest one and swap with the first one if necessary. So this is continuous to the end. Selection sort takes all of n square time in the worst case. There are many other sorting algorithms. Sorting is an important task in programming. We use sorting in many applications. There are many research done in this area to discover efficient sorting algorithms. There are many ways to sort. In this chapter, we're going to introduce insurgent sort, bubble sort, merge sort, quick sort, heap sort, and bucket radix sort. Let's first look at the insurgent sort. This is the animation for insurgent sort. Let's have 8 numbers. So I'm going to reset it. So this is the 8 numbers. So we start from the first number. This is already considered as sorted, as a sublist with one element. And now we're going to insert 30 to this sublist. So 30 is here. So these 2 numbers now already sorted in the sublist, 30, 51, and now insert 42. And now 92 is already here, it's in place, and 89 is inserted here. And now 38, it's going to be inserted right here in this position. And continue for 56 and 71. Now everything is sorted. So this is the algorithm. We're going to start from this I is range 1 to this is the end. It's the list is the last one here. The index is the list size -1. So we're going to insert list brackets I into a sorted sublist, and from the beginning and before the index I, and so that after this is done, so this list is sorted. So this is the algorithm, and here is the detailed implementation for the algorithm. So please note that we're going to perform this shift here is if you insert the element here, I'm going to 4, and you're going to insert in this location, index is 1. So you have to shift 9 and shift 5, and then insert 4. So the first thing, we're going to put 4 in the temporary location. This is the current element. And then we perform shift. And so compare this with this 9. If it's less, so you're going to shift. And compare with 5, less, shift. And now compare 2. It's great. So now you know you're going to put it into this location. So here is, and this is the while loop for this, compare and shift. Now look at the time complexity, and this is the overall time for sorting a list of size of n using insurgent sort. And so now for this, at the case iteration. So here's this last iteration. It's for the case iteration. So you may have to have just you have to compare and then shift. So compare and shift. So that's 2 times 2. And so there might be some other additional operations. So such as you do assignment, and so additional operations right here. It's a constant C. So add all this together, it is this. And so you're going to ignore the non-dominating terms. So we're going to keep only the last, the most significant part. It's n square. So the overall time complexity, it's order of n square for the insurgent sort. That is all for this section. Insurgent sort. We will continue in the next video on the bubble sort. See you on the next video.